Alright, so let's look at this again. We're looking at this ship, the BB-45, which is going to rescue this drone that went out and did whatever it was doing. We found last time that its displacement was 6 nautical miles, comma, minus 33 nautical miles, 6 nautical miles east, minus 33 nautical miles, or 33 nautical miles south, minus 33 nautical miles north. So now what we want to do is figure out what the average velocity over this is. So our average velocity was v is equal to delta x over delta t. Now this is a vector equation. What we now want to do is we want to figure out that delta t before we start worrying about all this other stuff. So delta t is equal to 10:20 when it's recovered, minus 7 a.m. when it's launched, which is 3:20, 3 hours, 20 minutes, which is 3 1/3 hours, or 200 minutes, whichever is going to be most useful. Okay. So here we just need to know how to change, subtract time, 3 1/3 hours. So next we want to take this number and plug it back in here, as well as using this one. So that's going to be 1 over 3 1/3 hours times 6 nautical miles, comma, minus 33 nautical miles. Okay, so let's do this here. This is actually 10/3. So that's 3/10 hour, 1 over hours, 6 nautical miles over, comma, minus 33 nautical miles. Okay, so we multiply by 3 and divide by 10. So we have 18/10 nautical miles per hour, and minus 33, or no, minus 99/10, because 3 times 33 nautical miles per hour. Okay, so 18 over 10, that's 1.8. Now, a nautical mile per hour is a knot, 1.8 knots, and 99/10 is minus 9.9 knots. And that's it. So we just had to divide each component by the change in time after we found the change in time. All right. So how did we do this? Well, previously we found this displacement. We plugged it into this equation. We did have to find delta t, and we used it here. And then we just used the trick that we talked about in the lecture bit. This is the example bit. And we distributed, like this 10 hours, we actually distributed the 3 to get from here to here. And did our math on each component, and we got our answer. So it's nice and linear, not the world's hardest thing. All right. Next we'll talk about directions and magnitudes and things like that and what they sort of mean. And then we'll go back and finish this example by finding the speed in the course, because it's nice that we know how fast you're going east and how fast you're going south, but we'd like to know just how fast are you going. We'd like to know what direction. And that's coming up next. Bye now.